Welcome to this predicted paper from On Maths. This paper represents the best guess for the upcoming exams. Please use this paper in addition to your other revision. You can complete a unique version of this paper by going to our On Maths site. On Maths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions, and mini mocks. If you like what we do, please consider subscribing. So we're given the formula for acceleration, but we're not given it for velocity, which is not a problem because we know that velocity is just the integral of acceleration, so we just need to integrate the acceleration. And so we're going to add 1 to the power, so it would be squared, and then we put that over what that is. There we are. This one's a bit more complicated because we've got to add 1 to the power, so 3 over 2, and then put that over the power. Now, because we're integrating, we need to add c at the end. So if we tidy that up a bit, so it'd be 7 over 2 t squared for the I component, and then, what is that, 28 over 3 t to the power of 3 over 2 for the j component. But we have this plus c at the end. So if we look at the question, it says that when t is 0, the velocity is 20i. So that's basically telling us that when all of this isn't there, this is 20i. So we can just put that on the end there. So 7 over 2 t squared I, 28 over 3 for the j, and then the c part is just going to be plus 20i. And what we want to do is combine the i's together. So we're just going to do 7 over 2 t squared plus 20i. That's our I component there. Okay, so we're asked to find out what the velocity or the speed is when t is 4. So we're just going to substitute in 4 into this. And for the I component, we'll get 76i. And for the j component, we will get 74.6, blah, 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 recurring j. Now, we're asked to find the speed, and to find the speed, which is obviously a magnitude, we just need to remember, if I get my lines out, that the I and the j component there, the speed is just this part here. So we've got I components and the j components, and the speed is this part here. So we're just going to use Pythagoras. So the speed is just going to be the square root of the I component squared plus the j component squared. And that will give us 106.541 blah blah blah. And to 3 significant figures, that would be 107. Now we should put units in, and so the question says it will be meters per second. I'm going to start focusing on this tan alpha is 3 over 4, because whenever you see that, you should probably do a quick sketch of a right angle triangle and just label on some other sides. So we've got alpha here. So tan alpha is 3 over 4. So we know that tan is opposite over adjacent. So that would be 3 and that would be 4. And we know through Pythagoras that the last side will be 5 because that's a 3, 4, 5 triangle. We will also know that sine alpha is the opposite, which is 3 over the adjacent, and cos alpha is the adjacent, which is 4 over the hypotenuse. Okay, let's have a look at the diagram next, and we first of all can easily label on the reaction. And we're told that we have a rough horizontal floor, which means there will be friction, and we are, I think, given the friction, there we are, the coefficient of the friction, but it does imply the fact that it's accelerating, which means that we've reached the maximum friction. So if we just label that on, and that's quite significant that we know it's the maximum friction, because we can then use mu r. Okay, next we know that it has a mass, like it weighs something, and that would be mg, so it's 20 is the mass, and g, which is 9.8. Right, next thing we can do is just split up this kind of diagonal force into a horizontal and a vertical force. And sometimes we don't do this on the diagram, but sometimes it's a bit easier if we've got space. So it says it's 60 newtons, so the horizontal force will be 60 cos alpha, and the vertical force will be 60 sine alpha. And looking at that now, I think that covers all of the forces that we have on the diagram. So the next thing we want to do is we want to resolve. We're going to do it vertically first. Now, looking at all of the forces going up, we have R, and we've got that 60 sine alpha. And we know it's not moving up or down, so that's going to be equal to, and then we just have the 20g there. Now, we can rearrange that to have it R equals. So it'll be R equals 20 times, and then g is 9.8. Take away, and then it would be 60 times, and we've already worked out that sine alpha is 3/5, so times 3/5, and we get that R is, and we can just leave that as 160. Next we need to resolve, actually I'll tell you what, before we resolve horizontally, we can actually do a step next. Let's just move that down a little bit, because we actually can work out what the friction is. So the F max, and the formula is mu r. Now we know mu because it's given to us in the questions, 0.07, and we know that the R is 160, and that will be 11.2. Okay, now we go resolve horizontally, and so we've got, we're going to use F equals ma with this. So we're going to work out all the forces. So the forces going to the right will be 60 cos alpha, and we're going to take away the opposing forces. So we're going to take away that F max that we've just calculated. So we're going to take away the 11.2, and there is an acceleration, so that will be equal to the acceleration, which is the mass times acceleration, so it'd be 20a. And we can scroll down now just to give ourselves a bit more room. And we can just rearrange this now. So we can have a equals, and it will be 60 times the cos alpha. So if we have a look up, will be 4/5 minus the 11.2, and then all of that over 20. And so that will be 1.84, and it's an acceleration, so it'll be meters per second squared. For part A, we had the force going up and to the right, so we had a right force and a vertically up force. With this one, we now can see that we still have that right force, but the force now, instead of going up, is going down, so there's a down component to it. Along with the 20g, that means we've got a much larger force going downwards. This means that the reaction force will be increased. Now, if the reaction force is increased, we know that the formula we used for the maximum for friction was mu, which has stayed the same, times the reaction, which has increased. Therefore, the friction will increase. So, this will increase r, which will increase the maximum for friction, which will decrease the acceleration. And the reason for that is if there's more friction, then the acceleration will obviously be smaller. With these kind of kinematic questions, I always find it useful just to write down the suvat and see what I know and see what I'm trying to find. So we're not interested in distance at all, so I'm just going to leave that blank. It says when time is 0, there is a speed of 0.5 meters per second. Now, we've got to be careful here because it's saying that it's moving north, so that would be a j component, so it would be 0.5 j for the initial velocity. Looking round, it says that the velocity at which we're interested in this question, the final velocity is going to be 16.8 I minus 0.7 j. We're asked for the acceleration, so I'm just going to put a question mark there because that's what we're looking for, and we know that the time is 24 at that point. So we've just got to work out what formula involves uvat, and that will be v equals u plus at. Velocity we already have, the 16.8 I minus 0.7 j. U is the 0.5 j plus, and the t is 24, and the a is the unknown. And we just need to rearrange this, so what we can do is we can put our lines in, and we can take away the 0.5 j from both sides, and so we've got 16.8 I, and that would be, 1.2 j minus 1.2 j, and then we can just divide both sides by 24, and that would be 0.7 I minus 0.05 j, and so A would be 0.7 I minus 0.05 j. So the value of the A we're looking for in the question is 0.7, and the B we're looking for is 0.05. As always, we're going to just write our suvat and find out what we're looking for and what we have. So looking at the question, R is the position at time t, so we're just looking here. So R will be the distance, so we'll just put that in as the distance. U already know is 0.5 j. The acceleration we've just worked out is 0.7 I minus 0.05 j. We don't really know the velocity at this point, but we're given the fact that the t, if we have a look, t is t seconds. Well, that's nice and easy. So t is t seconds. So these are the ones that we know. So we've got to figure out a formula that links them all, and that will be S equals ut plus half at squared, the complicated one. So S we know is R, which is quite nice because we want it in terms of t, so R in terms of t, so we want R equals what t. U is 0.5 j, and so it'd be 0.5 jt plus, and we've got half at squared, so half times a, which will be the 0.7 I minus 0.05 j, and then t squared. Like with many of these multi-part questions, it will ask you to work something out, and then the next question will require you to use that answer to progress the question. So part C actually uses the answer to part B. So if we have a look back, we've worked out what r is. Now, r is the distance in relation to the time. And one thing we know, when the boat is northeast of O, well, when it's exactly northeast, so if we have, let's show north and east. So we've got north and east. If it's exactly northeast, what do you notice about the vertical and the horizontal components? Well, it should be J, should it? We notice that I is equal to J when it's northeast. And what do you notice about part B? Well, we've got an I component, we've got a J component, but we need to work on that to be able to separate the I's and J's, because we've got like a J here, a J here, and an I here, so it's a bit messy. So we're going to start by rearranging that so we have an I and a J component, then we're going to get those equal to each other and find out what T is. So I'm just going to copy down my answer to B, so 0.5 JT plus half 0.7 I minus 0.05 JT squared. Okay, so let's break open those brackets first of all. And so that would be 0.35 I T squared minus 0.025 JT squared. And let's add the J's together. Oh, well, we'll subtract them because that will be a minus. And that should give us, well, actually we can't do that because they're T and T squared. So we're just going to just put them next to each other. So I'm going to put the I at the start. And instead of that, I'm just going to put the I at the end. So it'd be T squared I. So we've got this I component here all together nicely. And we're going to put the J components next to each other. So it will be plus 0.5 T minus 0.025 T squared. And then that will be the J component. So this whole bracket here is the J component. And as we said, the I's and the J's will be equal when it's exactly northeast. So what we can do is we can put 0.35 T squared, the I component, and we get it equal to the 0.5 T minus 0.025 T squared. Now we can put our lines in and start solving it. So first thing we can do is add the 0.025 T squared to both sides. So we can collect the T squared, so that would be 0.375 T squared equals 0.5 T. We can actually times both sides by 8, because if we do that, we get a nice 3T squared equals 4T, much easier to work with. And we can subtract the 4T from both sides. You might think we can divide the T, but we really shouldn't. We really shouldn't divide T because then we'll miss an answer. So we've got 3T squared minus 4T equals 0. Factorize it, and we've got T brackets 3T minus 4 equals 0. And we can figure out the fact that there's going to be two answers. There's going to be a T equals 0 and a T equals 4 over 3. Now the boat started at O, started at this point, so it's not really northeast of it, it's on it. And so the answer we give is this 4 over 3, and that's what we'll give as our answer. This question's very similar to part C. We're going to start by putting our suvat out and work out what we know and what we're trying to find. We're not interested in distance in this, but we do know that the initial velocity is 0.5 j. We don't actually know the final velocity when it is heading northeast, but I'm going to leave that as v because we're going to be doing the same as part C. We're just going to get the i's and the j component equal. The acceleration we know from previous questions is 0.7 I minus 0.05j, and the t is what we're trying to find. So we can either put a question mark or put a t there. We know the formula that links these is v equals u plus at. So it would be v equals u is 0.5j, and then plus, and I'm just going to multiply the t's here, so 0.7 ti minus 0.05 tj. Put the i's and the j's together, so we'll have the 0.7 ti, and then we've got the 0.5 which is here, minus the 0.05 t, this one here, and then all that's the j. I's, I components are equal to the j because it's heading northeast, similar to part C. So it would be 0.7 t equals 0.5 minus 0.05 t. Get our lines in. So we're going to add the 0.05 t both sides. So we can just put the components together. And so that will leave 0.75 t and the 0.5. Next we're going to divide by the 0.75. So we can have t equals, and that would be 2 over 3. So the time will be 2/3. The question says, why is the reaction from the drum to the ramp at point C in direction that's perpendicular to the ramp? So that's basically like this here. So this is the reaction at C. And the reason for that is given to us in the question, where it says that it is smooth, which means there's no friction. So we just need to highlight the fact that the drum is modelled as smooth. So there's no reaction, and therefore the reaction, well, there's no friction, sorry, therefore the reaction is perpendicular to the ramp. So we're asked to find the magnitude of the resultant force acting on the ramp A. If we have a look at the diagram, well, first of all, I notice we've got this tan theta equals 7 over 24. So we always try and quickly do a diagram for that. And so we're just going to start off with that diagram. So it's it'll be 7 and 24 theta, and then what we can do is we can put in our cos theta. So it's a 7, 24, 25 Pythagorean triplet, and cos is adjacent, which is 24 over hypotenuse, and sine theta is 7 over 25. Okay, and we're going to start by just labelling all of the forces that we have acting on this ramp. So we've got the normal reaction at A, and we're just going to label this as RA. We're also told that we have a friction force because it says it's a rough horizontal ground, and so there'll be a friction force here. Just label that as F. We're also told that the ramp has a mass of 20 kilograms, and it's 20 meters long, so that's going to be acting on the ramp in the middle, and so it would be somewhere here, and it's 20 G, and that will be acting 10 meters into the ramp. So to find the resultant force, or the magnitude of the resultant force, we'll need the RA and the F. That's basically what we're looking for. If we know both of those, then we can use Pythagoras to then work out what the magnitude is. So the first thing we're going to do is we're going to consider moments about point A, and we're going to have a look at all of the forces that are going clockwise and get them equal to all the forces going anti-clockwise. Now anti-clockwise isn't such a problem because it's just going to be this RC, but we have a bit of an issue here because going clockwise, we don't have the force perpendicular to the ramp. So what we're going to do is we're just going to sort of add it on. So figure out what the component there would be, and this angle here would just be the same. It would be the theta again, and so we'll see how we're going to do that when we start working it out. So let's start working out now, and we should always tell the examiner what we're doing. So we're just going to consider the moments about point A, and so we know that we're going to have clockwise, and we're going to get it equal to all of the anti-clockwise. We can get our lines in. So we've said that the anti-clockwise is the easier one. So the distance will be 11. So it'll be 11 times just the RC component. Now the clockwise, we've said the distance of it will be 10, and it's 20g, but it will be cos theta, because as we showed on the diagram, it's going at this angle here. So it'd be cos theta. Now we know what cos theta is because we've worked it out here. So we're going to know that that's 10 times 20g, and that's going to be times 24 over 25. And what I'm going to do is I'm just going to divide both sides by the 11 and just work it all out. So that'll be 171.054 blah blah blah. And you might want to just leave this in terms of g. It might make it a bit easier, but actually I kind of want to work out what the actual number is, because the next thing I'll do with that is I'll need an actual value for it. Okay, so the next thing I'm going to do is compare the forces going upwards and downwards. And so looking at this, we've got this RA here. We've got another part where we just need to split it up. So we're actually looking at this part here, the vertical component, and then we've got this 20g. And again, the reason why we're getting everything equal to each other is this word here, that it's equilibrium. It means it's not moving. And so I can just scroll this down a bit, give myself a bit more room, and we're going to compare up and down. Always show the examiner what it is that you are looking at doing. So we're comparing the up and the down forces and getting them equal. And we said that the RA plus that kind of part of RC, so it'd be RC cos theta, and that's equal just to the 20g, the downwards force. Let's get our lines in. So RA we don't know, that's what we're trying to find out. Cos theta, so well we've got RC from the previous one, so 171.054 blah blah blah, and we've worked out that cos theta is 24 over 25, so it'd be times 24 over 25 equals the 20g. Okay, next we're going to just subtract all of this from both sides. So just subtract them from both sides and you'll get RA is equal to 31.787 blah blah blah. Okay, next we're going to compare the left and the right, and again it's in equilibrium, so they're going to be equal to each other. And so we've got our friction force going right, and we've got each of the components here and here going the other way. This one's straight down, so it's not going to have a horizontal force. So it's just going to be the RC component. And so we are going to have the RC this time, obviously, because it's horizontal, it'll be sine theta, and that equals the friction. So we know that sine theta is 7/25, and we know what RC is, so it'd be 171.054 blah 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 times the 7/25 equals F. We should put our lines in, and then therefore F will equal 47.895 blah blah blah. And so we've said at the start that we needed to find RA and F, and when we find both of those, then we can just use Pythagoras. So we've got both of those, so now we can just simply use Pythagoras. So the magnitude is going to be the square root of 31.787 blah 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 squared plus 47.895 blah 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 squared, and that will be 57.5 to 3 significant figures, and it's a force, so therefore it's going to be newtons. So this questioner is asking us to go back to the diagram at the start of the question, and just imagine that instead of this centre of mass being here, it is somewhere over here, so it's closer to A. Well, what's going to happen? Well, have a think about what we did at the start of question B. What we considered is the clockwise and anti-clockwise forces, and we got them equal to each other. So we do that obviously by the force times the distance. If the distance decreases for the clockwise component, well, it means that the reaction required for the anti-clockwise will also decrease. So our answer to part C is that the magnitude of the normal reaction at C will decrease. So with all kinematic questions, we want to start this question by getting our suvat, and we are not really told where this formula comes from, but we notice it has a G component, so it must be a vertical. We must be looking at the vertical movement, and also there's no V component, so chances are we're looking at the peak, the maximum height, and it says the maximum point is 15 meters, and it's already 4 meters up. This diagram's quite misleading, really. So that's going to be 11 meters there, which it looks like it's a lot higher up than that. So the distance it's travelled vertically is 11 meters. The starting velocity, well, let's have a look at that. So we're looking at the horizontal component. So if this is alpha here, then it will be u sine alpha. And we don't really know what u is, because it just says that it's moving at speed u, and it's sine alpha because it's obviously the vertical component of that. V is 0 because at the peak it's going to have stopped, well, its speed is going to be 0. The acceleration, well, it's moving against gravity, so that would be minus g, and t we're not interested in. So the formula that links S, U, V and A is V squared equals U squared plus 2AS. Now this actually tallies with what we can see here. We can see these squareds here. So we know that the formula involves squares. So that will be 0 equals, and actually let's get our lines in. Try and make this a bit neat. So 0 equals u sine alpha squared plus 2 times minus g times 11. And so that will be u squared, just a capital U squared, sine squared alpha minus 22g. If we add 22g to both sides, and then divide by the sine squared alpha, both sides. And you can see that the a that we're asked to find, the a as the constant, is equal to the 22. So it would be u squared equals 22g over sine squared alpha. So there's quite a few parts to this question. We're going to start by having a look at the horizontal motion, and always just make sure you label what it is you're doing. So a horizontal motion between A and T. We're going to start by putting our suvat down and see what we know and what we're trying to find out. So looking back at the diagram, we know that the S is 50 because it tells us here, so it's 50 meters between the two. U we're already told is U, and this time it's cos alpha because it's the horizontal component. V we're not interested in, but acceleration we know is 0 because it's moving freely. It's a particle moving freely, so we're not looking at air resistance or anything like that. And T is what we're trying to find. So the formula linking those is S equals ut plus half at squared. And so let's get our lines in and find out what T is. So it's going to be 50 equals u cos alpha times T. And notice that because A is 0, it just gets rid of all of this. And then we're just going to divide by u cos alpha both sides. And so we'll get 50 over u cos alpha is equal to T. So we've got T in terms of u here. So next thing we're going to do is the vertical motion, again between A and T. And we're going to do our suvat. Okay, so we're told that the height of T is 2.75, but looking back at the diagram, A is 4 meters off the ground. So it's gone from 4 meters high and it's gone down to 2.75, so that's gone down 1.25 meters. U obviously is u sine alpha because it's a vertical component. V we're not interested. Again, A is minus g from the previous question, and T is what we're trying to find. So looking at what we have there, it's the same as the horizontal component. It's S equals ut plus half at squared. Get our lines in, and it's going to be minus 1.25 is equal to, and this time acceleration is there, so it's slightly harder. So it's going to be u sine alpha T plus half minus g T squared. Now we know what T is from the horizontal component. It's 50 over u cos alpha. So we're just going to substitute that in. So every time we see a T, we're going to put that in, so 50 over u cos alpha plus half, well, can we simplify that? So it would be minus half g, and it would be 50 over u cos alpha squared. So minus 1.25 is going to be 50 tan alpha, because we've got the sine divided by the cos, so, and the u's will cancel, and it would be minus 1250 g over u squared cos squared alpha. Now it's interesting we've got this u squared here, because if we go back to part A, we've worked out that u squared is 22g over sine squared alpha, so we can substitute that in, and we're going to move down because we'll need a lot more space for this working out here. So we're going to substitute that in, and so we've got 50 tan alpha minus, and then instead of the u squared, we're going to have 22g over sine squared alpha, then that's times cos squared alpha. Wow. Okay, so let's try and tackle this fraction a little bit more. So we notice we've got cos squared alpha, and we're dividing it by sine squared alpha, and so we can rewrite that as, well, first of all we can divide the 22, so that would be 625, and we can divide the g's out, so we can get rid of the g's, and cos squared alpha divided by sine squared alpha is just going to be cot squared alpha. And we know that cot is obviously 1 over tan, so we can rewrite that again to 625 tan squared alpha. Now straight away we're looking at this going, oh, this looks like a quadratic, because we've got kind of a number term, an x term, and an x squared term. Obviously instead of x it's in terms of tan. So our instincts here are immediately to make the squared positive, so we're going to have to move that squared to the right hand side, so we're going to add the 625 tan squared alpha to both sides. So it's going to be 625 tan squared alpha minus 1.25 equals 50 tan alpha, and then we just got to take away the 50 tan alpha, because we want to make sure that it equals 0. So it'll be, I might leave a line, 625 tan squared alpha minus 50 tan alpha minus 1.25 equals 0. Now we're just going to create a quadratic, and so we can either use the quadratic formula or we can just factorize it. So that would be 250 tan alpha plus 5, and that would be 10 tan alpha minus 1. And again, we could have just used the quadratic formula. And we're going to get them each equal to 0. So it would be 250 tan alpha plus 5 equals 0. Solve that. And so that is going to be, so take away 5 divided by 250, so that would be tan alpha equals, and that will cancel to 1 over 50, so minus 1 over 50. So alpha would be minus 1.145, and then get the other bracket equal to 0. So 10 tan alpha minus 1 equals 0. Add the 1 both sides, and divided by 10. So that would be tan alpha is equal to 1 over 10. So alpha would be 5.710 blah blah blah. And actually I just truncated that, so I should put blah 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 on that as well. Now alpha must be between 0 degrees and 90 degrees, because we can see in the diagram it must be between those two. And so therefore alpha to three significant figures will be 5.71 degrees. When we answer the question for question B, if we go back there now, we can see that for the horizontal movement we've put the acceleration at 0, so it didn't decelerate, which it naturally would because of air resistance. So one limitation is that there is no air resistance. And that's not the only answer that you can give, but that's definitely the one that strikes me first. So in this question, we're basically going to mix our answers to question A and question B together to find out what the time is, and a little bit more. So we're going to start with our answer to question A, where we said that u squared equals 22g over sine squared alpha. So let's just copy that down. So u squared equals 22g over sine squared. Now we said alpha, but if we have a look at question B, we found out that the answer was 5.710 blah blah blah. So it's going to be 5.710 blah blah blah. And we're going to just put our lines in. So it'll be a quick one, because all we need to do is square root both sides. And so we've got u equals, and it'll be 147.580 blah blah blah. Now all we need is a nice formula that gives us what t is if we know what u is. So we'll go back to question B and notice we've got a lovely little formula here, which says that to find t we just do 50 divided by u cos alpha. And so let's just undo that and let's go back to question D, and we're just going to write that down. So 50 equals u cos alpha times t. Just show the examiner where we're getting this from. So it'd be 50 equals, and we've just worked that out, so it would be 147.580 blah 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 times cos, and it's that 5.710 blah 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 times t, and then we're going to divide both sides by everything on this side apart from the t, and we'll get t equals 0.340 degrees to three significant figures.
You can complete a unique version of this paper by going to our OnMaths site. OnMaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions, and mini mocks. If you like what we do, please consider subscribing.